Okay, for today, we're finding the prime factorization of a given number using a factor tree. Let's back it up. Remember that a prime number is a number that only has 1 in itself as factors, or a number greater than 1 that's only divisible by 1 in itself. So right now we want to break these numbers down into their prime factorization, their prime numbers that we multiply together to get that number. So they can be very simple, like 35. We all know that 5 times 7 equals 35. Both 5 and 7 are prime. The prime factorization of 35 is 5 times 7. But they may not always be that easy. If we look at 42, for example, what two numbers do I multiply to get 42? 6 and 7. 6 times 7. 7 is prime, so we'll circle it. But 6 is not prime. So we know that 2 times 3 equals 6. 2 and 3 are both prime. So 2 times 3 times 7 is the prime factorization of 42. But what do we do when the numbers get larger? Like 144, for example. Well, 12 times 12 is 144. 12 is not a prime number. 2 times 6 equals 12. 2 is a prime number. We'll circle it so we can move on. 6. 2 times 3 equals 6. 2 and 3 are both prime. So when we group that, we have 2 times 2 times 2 times 2 times 3 times 3. And that's kind of spread out. So we need to use exponents to bring that together. So we have 4 2s. So that would be 2 to the 4th power times 3 squared, or 3 to the 2nd power. We get to 96. Well, we might look at that and say, well, I can't remember my multiplication facts. Is it 7 times 12? Is it 8 times 12? But we can use divisibility rules. We can add 9 plus 6 together. It equals 15. So if we add the digits in the number together and it's a multiple of 3, we know we can divide it by 3. We can see that it ends in 6. That's an even number, so it's divisible by 2. So we have different options. But if we knew our multiplication facts, that would be 8 times 12. They're not prime. 2 times 4. 4 is not prime. Break it down further. 12. I'll use 3 times 4 this time. 3 is prime. 4 is not. Finally, when I regroup my prime numbers, I have 2 times 2 times 2 times 2 times 2. One too many 2's. Times 3. Now I'm going to rewrite that using exponents. So it would be 2 to the 5th power times 3. Lastly, we have 132. So using our divisibility rules, I know that 1 plus 3 plus 2 equals 6, so it's divisible by 3. So 132 divided by 3 equals 64. 3 is prime, 64 is not. So 8 times 8. That'd be 2 times 4. 2 times 4. Go a little further. 2 times 2 and 2 times 2. So when I finally rewrite that all out, we have 2 times 2 times 2 times 2 times 3, or 2 to the 6th power times 3. There we go, using a tree diagram. All right, so we looked at the tree diagram, or factor tree, as it's called, because it looks like a pine tree or a Christmas tree with decorations. But what is this ladder method? Well, it's not very much different. So if we have 66, it's an even number. So we can divide that by 2. Okay. Draw a little neater. 66 divided by 2 is 33. 33 is not prime. So when you divide it by a prime number, we'll divide it by 3. We have 11. So 2, 3, and 11 are prime numbers. 2 times 3 times 11. What about 125? Well, it ends in a 5. The divisibility rule says I can then divide it by 5. So 125 divided by 5 is 25. 25 divided by 5 is 5. They're all prime. 5 times 5 times 5, or 5 to the third power, or 5 cubed. Last we have 72. 72 is an even number, so I can divide it by 2. 72 divided by 2, remember 2 is prime, it's 36. 36 divided by 3, 3 is prime, it's 12. 12 divided by 3 is 4. 4 divided by 3 is 4 divided by 2 is 2. Now we have all our prime. So we rewrite that 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared. That's pretty much it for prime factorization. You can choose either method, whatever works best for you, or the one that is easiest for you. Thank you.